guys! So today we're going to be looking at Chapter 9, Section 1, Right Triangle Trigonometry, Part 2. So we're going to be looking at today trigonomic values for special angles. Right here we have two different right angles, and they're special because we often see them, they occur frequently. One of them is the 30, 60, 90 degree right angle, where if you notice, one angle is 30 degrees, another one is 60 degrees, and the last one is 90 degrees. The other common one that we have is the 45, 45, 90 degree angle, which is 45 on one side, 45 on another, and the last angle is 90 degrees. The reason why it's so common is because we can identify the ratio, which will later feature help us with finding lengths. So, best way to think about it is that the length of the side that is opposite of the 60 degree is always square root of 3. The opposite of 30 degrees is always 1. Opposite of 90 degrees is always 2, and that's the ratio that we will be providing. Same goes for 45. 45's opposite is 1. 45 degrees opposite, it should be 1, and then the 90 degree angle should be square root of 2. So if I were to try and find out what the sine of 60 degrees is, I go to 60 degrees and I look at the opposite side, which is the square root of 3. And then underneath is the hypotenuse, which would be the opposite of the 90 degrees. So it would be a square root of 3 over 2. Cosine is again the adjacent, so the side next to 60 degrees, and the hypotenuse, which is 2. So we get 1 over 2. Tangent is the opposite side, square root of 3, and the adjacent side, 1. So we get square root of 3 over 1. Okay. For sine of 30, the opposite is 1. So I'm going to put 1 down first. Then the hypotenuse is 2. So it'll be 1 over 2. For cosine of 30, it's the adjacent over the hypotenuse. So square root of 3 over 2. And then for tangent of 30, we have opposite over adjacent. 1 over square root of 3. Which again, reminder, make sure that you don't have a radical sign on the bottom of your fraction. So we got to multiply square root of 3 to both sides. That gives us square root of 3 over 3. Because again, you cannot have a radical sign on the bottom of your fraction. That's not allowed. For the sine of 45, again, because we have the same degrees, we just have to find one of them. So for the first one we have is sine of 45 is going to be the opposite versus the hypotenuse. So 1 over square root of 2. Again, because we have a square root on the bottom, gotta get rid of it by multiplying square root of 2 to both the bottom and the top. That's going to equal 2 square root of 2 over 2. Next one is cosine. So again, with the cosine, adjacent over a hypotenuse, which is just the same as sine. So I'll just write down the square root of 2 over 2. Oops, sorry. Square root 2 over 2. And the last one is tangent. Tangent is opposite side over the adjacent. So 1 over 1. And so these are going to be the ratios that we're going to be using to help us identify missing lengths of sides. Okay. All right, so finding the unknown side length. Let's say you're asked here to find the length of x for the right triangle. So we have here x that's missing, but we are given 30 degrees, and we're also given the length of the hypotenuse, which is 8. So from this, I can automatically assume that we have the 30 60, and I'll write down 60 right up here. And we have a 90-degree angle. So what I'm going to do right now is I want to take my drawing from over here and write it down here on the side, just to sketch it out. Okay, so I have my right triangle. 30 degrees is down here. So I want to make sure that I know what the opposite side would be for 30 degrees. So the opposite side of 30 degrees was 1. So I'll write down that the opposite side of 30 degrees is supposed to be 1. Again, this is the right angle, 60 degrees. I want it to mirror my original image exactly. The opposite length of 60 degrees, let's see, opposite length of 60 degrees is square root of 3. So I'll write down that this is square root of 3. And then our hypotenuse, which is the opposite of the 90 degrees, is 2. So I'll write down that the length should be 2. Now that we have a mirror image of both, now we can start comparing. So for the first one, what's given to us is the hypotenuse. Now write down this is the hypotenuse. We're also wanting to identify either the adjacent side to 30, or we could say the opposite side to 60, whatever works best for you. I will just say that this is going to focus on the 30, and then I'll say that this is the adjacent side. So adjacent to 30 degrees. Okay, so it's right next to the 30 degrees. If that's the case, then what I could do is I could write down that we have cosine of the 30 degrees. And if I were to look at the cosine of 30 degrees, it's always adjacent over hypotenuse, right? Adjacent over hypotenuse, which is x over 8. Cool. Now, whatever I do to this equation or ratio, I want to do the same to over here. I want to find cosine 30 degrees and see what that ratio would be from our rules that we already have given to us. So for the 30 degrees cosine, we would have square root of 3 over 2. So I'll write down square root of 3 over 2. That should be our ratio that we're supposed to follow. So once I have this ratio, what I could do is I can compare both ratios. The square root of 3 over 2 has to equal to x over 8. And now I can start identifying what x is. I could do this by cross multiplying first. So I'll multiply x times 2. I'll multiply 8 times square root of 3. And I get 8 times square root of 3 equals to 2x. And then from there, I'm just going to divide 2 to both sides. Divide 2 to both sides. That's going to leave me with 4 square root of 3 equaling to x. And that would be how I find my x value. So x value would be 4 square root of 3. That would be my final answer. Done. Okay. Okay, so let's look at a different one now. Let's say we don't have a 30, 60 degree or a 30, 60, 90 degree angle. We also don't have a 45, 45, 90. Instead, we have a 28 degree. In this case, we will be having to use our calculator. So if we have 28 degrees, I know from the start that the degree of an entire triangle should be 180 degrees. And on top of that, I know that this is supposed to be 90 degrees. So all I'm going to do is take my total amount of degrees from a triangle and subtract it with the 90 degrees and the 28 degrees. That should help me figure out what the degree is over there. So 28 degrees plus 90 degrees that's going to equal 262 degrees. So that should be how many degrees I have left over in my triangle right here. Okay. And so we're trying to solve for the triangle ABC. So far we have the degree, which is cool, but we need to find two missing lanes over here and over here. One of them is supposed to be for C, the other one's supposed to be for lowercase b. And so then we're going to figure out what those lanes are as well. So what we can do is we can use our trigonometric ratios. So I like to focus based off of what's given to us. So if they already give us 28 degrees and they give us 15, I'd rather use what's given to us to find out what C is and what B is. So let's start off with trying to find out what C is equal to. What I know is that 28 degrees, this is going to be my adjacent side. Adjacent to the 28 degrees. I also know that C is supposed to be the hypotenuse. Hypotenuse, because again, it is opposite of the 90-degree angle. So, based off of that, I could use cosine, because I know that cosine's ratio for 28 degrees would be the adjacent over the hypotenuse, which is 15, because we already know the length of this side should be 15, and it's over C, which we don't know yet. So all I need to do now is solve this out. So I'm going to get the cosine. Let me just get some more space here. I have here cosine 28 degrees equaling to 15 over C. I'm going to move the C so that I can isolate it. So all I'm going to do is multiply C to both sides. And that will give me C times cosine of 28 degrees equaling to 15. Because again, that just cancels out the C from the top and bottom. And then I'm going to divide both sides by cosine of 28 degrees. That way I can get rid of the cosine and isolate my C. Cosine 28 degrees, that equals to C, equaling to 15 over 28 degrees. So right here, I'm gonna go to my calculator. And let me try and move it like this. So I'm gonna start off with the fraction, 15 on top. On the bottom, I'm gonna have, again, cosine of 28. And that's going to give me my final answer, which is 16.988. I'm going to round to the nearest hundreds place, so we get 16.99. Cool. Okay, so at least I know the length of C, which is 16.99. Now, I'm still going to just leave this alone. I want to focus on what's already given to me so that it prevents me from making less errors. So I'll still focus on the 28 degrees and the B equaling to 15 degrees. Since it's the adjacent side, I also know that B is opposite of 28 degrees. So I'll write down B is supposed to be opposite to the 28 degrees. So if I have the adjacent side, but I need the opposite side, I know that I could use the tangent ratio, because I know that tangent is supposed to be opposite over adjacent. If that's the case, I can use opposite, which is the B value, and divide it with 15. And again, from here, I just need to solve for B. So if I have here tangent 28 degrees equaling to B over 15. I can get rid of the 15 by multiplying 15 to both sides. Multiply 15 on both sides. That's going to cancel out the 15 on the bottom. Isolate my b, and I'm left with b equaling to 15 times tangent 28 degrees. And that will give me my length. So again, let's try it out with the calculator. Take out the calculator right here. Okay, so clear it or enter a new one. I'm going to write down 15 times the function is tangent 28. Close parenthesis, and we get our answer. We should get our length, which is b, equaling to 7.975, and that rounds up to b equaling to 7.98. So that would be my other length. So I now have the other length, which is 7.98. Cool. So now that I have my answers, I could write them all out. The first one that I found was the degree of b. So I could write down here that b's degree is 62 degrees. I also found the length of lowercase b. So right here we get 7.98. And then the length of c, lowercase c, which is 16.99. And so those would be my 3 final answers. Oh, also make sure that it's not actually the equal to sign. It has to be the rounding because we were rounding. So I'll put the squiggly equal to like that. That would be my final answer. Done. So hopefully this helped. Good luck.